everyone. One of the very interesting topics in data structure is sorting, and insertion sort is one of the simplest sorting techniques which we are going to see in this particular video lecture. Let us watch a small video clip before we continue further.
So I have 6 cards in my hand. Come on, let's arrange it. First, let me find the best place for 0. Now 8. One, 7, and 5. Let me check if it is in the right order. 0, 1, 3, 5, 7, and 8.
Now, let us answer these two questions. Why is this sorting called a simple sorting technique? All of us have come across situations like this when we had some 10 cards in our hands and we wanted to arrange them. When we wanted to arrange them, we had actually followed this technique without knowing this name only. Now, let us try to understand why this is called an insertion sort. Insertion sort basically has two sublists. One is a sublist which is considered to be sorted, and the other sublist is said to be unsorted sublist. Now, the child started with the first number with considering that as a sorted sublist. The first pass starts by taking the second card and placing it in the right position with respect to the first card. That is the first sublist, sorted sublist. Now, the insertion of the second card is the second pass. The child removed the second card in the unsorted sublist and the position was found in the sorted sublist and inserted. This was continued for the consecutive cards. Now, this technique is followed for all the elements in the unsorted sublist until all the elements in the unsorted sublist find their positions into the sorted sublist. This process gets over. Now let us see how insertion sort works. Let us take an example of 7 numbers in the array. The array now consists of 7 integers. These 7 integers have to be sorted according to ascending order. Now this array of numbers consists of 2 sublists. One sublist is a sorted sublist. Here the sorted sublist is considered to be the number 6 only. We consider only one number, so it is sorted. Now the second sublist is the unsorted sublist. The unsorted sublist consists of all the numbers starting from the second element till the last element, say nth element. And now let us start with the pass 1. In pass 1, what we did with the cards was we started with the second card. Now here we will start with the second element in the array 4. Watch this. The second element in the array is now put into a temporary variable space. Now this temp variable has the number 4. A space is created in the sorted sublist. Now this empty space moves into the sorted sublist. The next thing that we have to do is we should find the correct location to place this element in the temp variable. How to find the correct place for this temporary variable? We need to compare this variable number 4, the value in this variable temp number 4, with each one of the elements starting from this end, right end, to the left end. We start from the right end and we move towards the left end. So here we start with 6. So we compare 4 with 6. 4 is lesser than 6. So 6 is shifted to this empty space. And now 4 is inserted into this space. Hence, the element 4 takes its correct position, is inserted into its right position at the end of pass 1. What happens at pass 2? At pass 2, the third element, number 8, is placed in the temp variable. And now we'll have to find the correct location of temporary variable. And this temporary variable's value being 8 takes this position after 6. Takes the position after 6, and this is denoted by a red color. And now you can see that we need not compare any further. 8 can occupy the position after 6. With this, the pass 2 gets over. At the end of pass 2, we have actually found the right position to insert the element 8. Watch what happens. Now we have the next element 2 for the pass 3. You can see how 2 places itself in the position before 4. Now 2 takes its position at the end of pass 3. Now let us take the next pass. The element 1 finds its position by comparing it with elements starting from the right end of the sorted sublist till the left end. And 1 now occupies its correct position at the end of pass 4. Similarly, for element 3 and for element 5. Now let's answer this question. Given n elements, how many passes are required to sort them? We know that the first element is already sorted, and so we started pass 1 from the second element. Obviously, the number of passes is equal to n minus 1. Hope this lecture helped you to understand the basic concept of insertion sort. Happy learning. Thank you.